35.
Hello, everyone, and welcome to another Grafana Office Hours. I'm Nicole van der Hoeven. I think this is our second episode of the year. Is that right? Is it just the second? Feels like it's been
Yeah, I
more.
think it is.
Okay. Well, today I've
I'm on.
got my co-host.
Hello, I'm Paul Balogh, another developer advocate here at Grafana.
And also, for the first time, we've got Ryan Perry. Yay! Welcome to the stream.
Woo, thank you for having me. Excited to be here.
Who
Yeah,
are you
excited to be here.
anyway?
Yeah, who am I?
What are
I'm
you doing
I'm
here?
Ryan. Yeah, that's a deep question. How deep should I go? But yeah, no, I'm Ryan. I'm one of the founders of Pyroscope, and yeah, we started Pyroscope a while back. Obviously, we have since joined Grafana. I'm sure we'll get into a lot of the reasons why and all that stuff. But yeah, I've been working on continuous profiling for a while now. Been worn a bunch of different hats: software engineer, product person, salesperson, etc. And so, yeah, I've kind of looked at profiling from a lot of different angles, and very excited to talk with you guys about it today.
So why is that? How did you get into continuous profiling? Was that like always something that you were into, or is that just a recent evolution of things that the path that you were already on?
Yeah, I mean, when I was 7, I actually no, I'm kidding. So,
Oh, okay. I thought this was a for
Uh-oh, a
real thing. Like,
prodigy.
wow. Yeah.
A true prodigy.
yeah,
I just wanted to be a
yeah, so,
profiler.
right.
I
Continuous
dreamed of
profiling has
flame
always been
graphs.
my calling. Yeah, exactly. No, so I kind of got into continuous profiling. So I worked with Dimitri, who's my other co-founder, at my first job in the software world. I did like a coding boot camp. I guess if I go way back, I went to business school, and then I was like, I don't know,
Hmm.
software seems cooler, more fun, whatever. And so then I did a coding boot camp, ended up in the software world, got my first job at this company where we did a lot of performance intensive work. And that was where we started using profiling tools in order to cut costs and improve the performance there. And that was where the seed was planted there of like, this is like pretty cool. We built like a very hacky version of what now exists as Pyroscope at that company. And it's called Sensor Tower. They do like mobile app analytics stuff. And so we built a hacky version there, and then we were like, we saw that like Loki had a database for logs, Tempo had a database for for traces. And so then we were like, okay, there's no profiling database that exists. If we could figure out how to kind of collect this data continuously, we could kind of bring the benefits that we got to everybody. And it's kind of every engineer's dream to have a really cool open source project that becomes popular. And so we kind of took a crack at it, and kind of the chips fell in the right direction.
Awesome. And all
So
at 7
initially,
years old. That's crazy.
Yeah. Yeah, right. All this
wow.
was at 7 years old. No, this was post college.
Real prodigy. So you actually built what became Pyroscope just to solve your own problems.
Yeah, definitely. So yeah, like I said, so there's different kinds of profiling, right? So it's like there's a lot of open source profiling is not a new concept, right? It's like, something that has been around since since I was 7, even before then. And but it existed in a much different form where you would kind of maybe like SSH into a machine that wasn't, functioning the way that you expected it to. You would kind of like grab a profile, which I guess we haven't explained exactly what it is. It's like a flame graph. It's a snapshot. A way I often describe it is like a very fancy pie chart that tells you, which lines of code your application is working on. And so you would kind of do that in an ad hoc way occasionally. But like, let's say something happened yesterday, you got paged for it. You wake up this morning, everything's on fire. If you didn't grab the profile at that time, you've missed out on like the information you need in order to resolve the issue. And so that was kind of the, innovation or enhancement that we made to this, is making it so that you're always storing this data over time. So you can like go back and, compare last week to this week, or go back and see what was happening yesterday, or whatever it might be.
That's cool. Yeah, I know. Back in my day, I had to depend on a JVM heap dump and
Yeah,
analyze that,
exactly.
and hopefully you caught it at the right time, right?
Which
Yeah.
you never did, so I come from the testing world, and what I would do before running a performance test is I'd have to like SSH in manually to each one and be like, okay, start, because we can't leave it running forever. Like, I remember once I forgot to stop it after the test, and it basically just froze because of all of the data that it had collected. I'm like, well, that's gone.
Yep.
Great. Now I have to restart the test, I guess. And that's why that was part of what the pain was for me. And there was also significant overhead. So it was very, I always tried to make sure that the collection itself didn't cause that component to overload. There's so many issues with it, but like, how did you solve that?
Yeah, so that's actually yeah, that was kind of the key piece. Was it was like, okay, can we find a way to get this information in a like low overhead way, right?
Right.
And so I would say historically, yeah, back if you were doing those heap dumps a long time ago, and even as recently as maybe like 5 or 6 years ago, the most common way of profiling was, yeah, you would, hit a button, you would start, it would maybe like hook into like the method invocations and say, start the stopwatch, stop the stopwatch, this code was running for this amount of time. And that, yeah, if you're doing that all the time, that can be very expensive. The way that the kind of improvement that was made with a lot of these open source profilers that didn't store the data, but at least got the data in a low overhead way, is that they, from a separate process, they look at the stack trace of your application, X times per second, usually like the default something like 100 times per second. And it's able to then basically collect that data without blocking your application. If you do leave it running forever, it's just kind of a very minimal overhead of it just kind of looking at the stack trace and saying, what is at the bottom of the stack trace right now, and what is the, the full chain of functions look like. And then it kind of, morphs that into a tree and then a human readable form of flamegraph. And so basically a lot of these on the client side, really low overhead profilers exist. And then it becomes a matter of how do you store this data efficiently, and how do you query it efficiently, which we did a bunch of things to make that more efficient as well.
Well, you mentioned the visualization of it, and that was also the problem, because even when I did get the metrics, it was like, okay, what exactly am I looking at? Am I looking at the highest point, or am I trying to get the mean in some way, or like, what is it? Should it be by time? Because the script might be doing and touching different components at different times, so you have to make sure that it's at that specific time that you're measuring it. Or do you plot the whole thing on a logarithmic scale to reduce the influence of outliers? And now it's just completely different. Now it's like flame graphs that you're comparing.
Yeah,
How does that work?
I would say it's not completely different. I mean, I still think that there is, I mean, yeah, there's still kind of that element of time, but yeah, so you're getting these flame graphs in different time chunks, and then basically we store them at their most granular level, and then at query time we'll then aggregate them into the time period you're looking at. So if you're like, oh, we were experiencing this issue for a full hour or a full day, you can select a day's worth of data and get one flame graph for that entire day. And then maybe you care about, server A versus server B, similar to Prometheus or Loki or whatever. You can, add these metadata to the profile so that you can say, not only do I want to see the last day, but I want to see the last day for this specific server, this specific, region or pod or namespace or whatever labels or metadatas that you want. And so, it still does have that time element a little bit,
Mhm.
but But then at the end of the day, it kind of boils down into the actual flame graph itself, and understanding the performance attached to those two dimensions, either time, metadata, or both.
Yeah. The flame graph as a visualization method, I guess, wasn't really something that was on my radar. So it always felt like either a snapshot or something that was so heavily aggregated that it lost a lot of the detail. Flame graph
Mhm.
seemed to be like a compromise between those.
Yeah. In this case, that's the nice thing about flame graphs and profiling, is that you can get that granular level of detail, or you can zoom out. And so that's kind of the key piece. That's why we called it Pyroscope. It's like pyro, flame graph,
Flame,
scope.
yeah.
You can kind of it's like a microscope you can zoom
Yeah.
in, or a telescope you can zoom out. And so you can get that code level detail, for it, anything down to even a specific API request that lasted, let's say like 200 milliseconds. You can get a profile for that, or you can get a profile for your entire system. Like we use it at Grafana. I can get a profile for every single line of code that runs at Grafana, which is a lot of code, and see it in one giant, honestly, very hard to read flame graph at that point. But we've done it before. And then sometimes it actually is useful, because there's some like libraries, for example, that we use across the entire company, like obviously, or maybe not obviously, like Loki, Mimir, Tempo, Pyroscope. We all share certain pieces of our architecture.
Yeah.
And so, for something like that, looking at a flame graph for the entire, entirety of all of our databases, we can see like, oh, if we want to, cut costs 10%, there's this chunk of the collective flame graph that's consuming a lot of resources. Maybe we should go look at that and be able to improve that, which we have done a couple times.
Yeah, I don't know. Flame graphs are just those visual representations that are like the coolest thing ever. I mean, they're even great on t-shirts.
Oh, wow.
So, yeah,
I don't have that.
Well, you had to be at KubeCon North America. I was there at the booth, and I was hanging out with Dimitri quite a bit. And then,
Oh, man.
yeah. So I snuck one of these. These are the old ones, I think. So,
there's
why.
Some, I gotta get you the updated swag. We've got a couple of that's been one of the best parts about joining Grafana, is we got some crazy designers. So we got some really cool swag. Hopefully you make it out to the next KubeCon in France, or the next time I'm with you in person. I'll make sure to get you.
Bring me one. I would like one
Yeah.
at KubeCon. I just have the Grot one right now.
There you go.
The lightsaber.
I still need to get
one.
one of those. I have yet to get one of those. Yeah,
we need to get a combined one, because that was our I don't know if you guys saw, that was our hackathon project, was Flame Grot AI. So it was like we had Grot, who was
nice,
for flame graphs, and so I want to do one that has
both.
The Grot, plus the flame graph.
So tell us about Grafana. Like how did you come to join Grafana, and what has that changed?
Yeah. It's been interesting. So once we started Pyroscope, we started it back in January of 2021, and we joined Y Combinator. So we were like going through that like accelerator and stuff, and we had big ambitions of building like a really comprehensive observability suite. Obviously we were starting with profiling, because that's what we used and we're familiar with. But we eventually, the initial plan was like, okay, we'll start with profiling, and then we'll expand into traces, expand into logs, expand into metrics. And then as time went on, honestly, we just we really like profiling, and there's a really good solution out there that already does logs, metrics, and traces. And so we've been talking with Grafana from the beginning. Because I mean, even when we were just Pyroscope on our own, everybody would ask like, okay, I have all the rest of my data inside of Grafana. Like, where, is there some way I can get my profiling data in there too? And so we had a Grafana plugin and all that stuff. And so, we always knew that there might be a chance. And then, honestly, the, everything kind of fell the right way, where at a certain point, Grafana had released Flare, which was like, basically a similar thing to Pyroscope, a profiling database. And a lot of things were like really aligned. And we were like, okay, well, if we're all working on the same thing, like why not work together? And so Grafana had reached out to us, and we were super interested. And so we kind of got together with the Flare team, liked what they were doing, they liked what we were doing. Things complemented each other in a really nice way. Like we had focused a lot on the instrumentation side, on getting all this profiling data into the database, and then they had kind of that architecture that was inspired by Mimir and Loki and Tempo that was really proven at massive scale. And so we kind of just combined the two of those, and then we had the visualization and put all of it together, and it all just like worked out. Everything fit together very smoothly once we joined, to the point where we were able to release Pyroscope 1.0, release the GA of Grafana Cloud profiles, all within like a couple months, because everything was just so compatible already.
Yeah.
No, that's cool. Yeah, and I thought I had heard something about that there was that little modification on the back end for the storage of the actual profile data to kind of bring it in line with the rest of the LGTM stack. That's cool. Yep. That's good. It was able to be done. I mean, because originally, were you guys using like was it InfluxDB on the back end or something?
We were using an open source. Like the key piece was like our object storage. And so we actually had like two different architectures. Like one was separate for like the cloud, one was separate for open source. And essentially it was called BadgerDB. And BadgerDB does not scale horizontally. So basically you could only grow Pyroscope to as big as a, hulking instance you could get from AWS or whoever you use. And so that's like nice. But it's like, obviously, at a certain point, if our whole thing is like, we want you to do continuous profiling, and then you're like, well, now I can't scale my database, like that, that's a huge issue. And so that was the biggest thing that we were able to pick up once joining Grafana, is that now it's horizontally scalable. It will literally scale to effectively any amount of data that you're willing to send to it.
Yeah, that's awesome. Yeah, and that's definitely been proven, it seems like, as far as the storage capacity of those backends.
Oh yeah, cool. Absolutely. We've seen some pretty both in our cloud, and then also just people running it open source. We've seen some pretty massive deployments of continuous profiling. Certain industries use it more than others. I've noticed, like rideshare, like there's a lot of rideshare companies that are using it pretty heavily. Fintech, areas where like latency is super important. Those are ones where we see people really leverage continuous profiling super heavily.
So Ryan, I'm going to ask some basic questions here, and you can always correct me if I'm wrong, because I really don't know that much about this. That's why I wanted to have you on here to ask you my questions.
Let's do it.
It sounds to me like continuous profiles are metrics. Is that an oversimplification? Are you collecting metrics with certain tags?
They are, I think, at its very, philosophically, at its very core, everything could be a metric. I would say, ultimately what a profile is a metric, at the line level for some sort of resource usage. And so, if it's CPU, for example, when you're looking at a profile, and I can show some if you'd like, but when you're looking at a profile, the metric that it's counting is, what amount of time, for example, was spent on this specific function. And so, you're getting that just in a very condensed way where you can see it all at once. So, the same way that a pie chart is technically, the underlying metrics of the data that informs that pie chart, the same is true for a flame graph or a profile. It's, the underlying metrics of the data that populates the flame graph.
I guess my follow-up question is, why do continuous profiles have to be a separate telemetry signal? Why does there have to be a separate database for continuous profiles instead of just pushing everything to Prometheus, which I believe Pyroscope can do, right?
Yeah. So that is because if you just pushed everything, the amount of data that you would be sending is like pretty astronomical. So in storing it and saving it as a collective profile, so as a set of metrics, you are basically saving it in the form that ultimately it needs to be rendered in, right? Like if you were saving all these individually to then build a profile, you're going to have to query a bunch, some profiles can have thousands of different, metrics all in one profile, right? And so if you did put all that into like Prometheus or some metrics database, now you have to not only query all of those separately, but then you have to spin the CPU to, piece them together and merge them and make them look pretty and color them and all that kind of stuff. Whereas if you store them as a set, you can kind of maintain the relationships of like A to B calls C calls D, and it allows you to basically just keep things much more compact and make a database that is specifically oriented towards, this kind of like relation, kind of like relation-based data where things are related to each other.
Okay. Well, I would love to get to the demo for how Pyroscope works, and then maybe after that I'll see if I still have questions, and then we can circle back around to it.
Let's see some
Sure.
flame graphs.
Yeah.
Let me share my screen here.
Yep,
Yeah,
you're
there's
good.
Okay, yeah, there's a bunch of things in here. Yeah, so before I go like too deep, I will show just like real quick, like what, we've been talking about flame graphs in case anyone has not, seen a flame graph or knows how they work. So basically, let's say you have a function here that, is main. That's going to be the top of your flame graph. And the way that you read this is that the width, like I said, is like 100%. And so if the width of this, everything starts in the main function. So no matter what's happening, that originated from this function. And then you have, do a lot, do little, and then each of those call the function that was prepare. And so, here main calls do a lot calls prepare. And so the way that shows up in a flame graph is that main calls do a lot, which calls prepare, and then it also calls do little, which calls prepare. And then here, so for example, let's say you're spending $100 on your servers, 65 of those dollars are spent running this function, and 26 of those dollars are spent running this function. And so, or if you're looking at it from a time perspective, 65% of the time is spent doing something, doing a lot, and 26% of the time is spent in this function where it's doing little. So I just wanted to show that of how the flame graph itself works. But yeah, so I'll go through like a quick demo. There's a bunch of slides here, but for this demo, I just mentioned that that rideshare companies tend to get a lot of value from profiling. So for this demo, I'll show kind of in a rideshare world, what this might look like, but the same, it's kind of generic. So like the same thing could be applied to anything. And so the way Pyroscope works is, let's say you have 3 different servers, one in the east, one in the north, one in the south, and you add the region label attached to those. And then you have 3 different routes. You can either order a car, a bike, or a scooter, and you add the vehicle label to that. And so the way continuous profiling works is it's going to collect all of this, all of these profiles periodically, every 15 seconds by default, but that's configurable. And it's going to store them on the server again with this associated metadata where it can be, queried and where it can be queried. So the way that shows up inside of Grafana is, so there's basically 3 views. I'm going to start with this one just because it's most closely related to what I was just showing you. So again, there were those 3 regions. You have east, north, and south. And so what this does is now you can start to get more insights as to where your resource utilization is going for these different, for these different regions, for these different servers. And so here what we're seeing is that the north region is, we're looking at CPU. We've, we can group by a number of different labels here. Right now we're grouping by the region label. And here I can see that 63% of the CPU for our whole application is being spent on the north region. 16% on the east region, 20% on the south region. And so if I look at, each of these, I can see the flame graph associated with each of them. And so not only do I just know that 63% is spent on this region, but of that 63%, I know that most of the time is spent in this specific function, 87% in this case. And so that's really useful, again, for if you're trying to cut costs, or maybe there's an incident happening and these all should be equal, but for some reason there's an incident causing this to consume more resources. And so one of the big benefits of Pyroscope, as I mentioned before, is being able to, let me hit refresh here, being able to then kind of compare and analyze this profiling data. So let's say I want to see what is the difference between, this blue east region and this green north region. I can hit the two of these, hit compare tags, and basically now what this is going to allow me to do is sort of, zoom in. I can select different time periods and different labels. So what we're looking at here is now we're seeing those flame graphs side by side. On the left side, we've selected, 1030 to 1035 for the east region. On the right side, we've selected, 1050 to 1055 for the north region. And I can start to look at these profiles side by side and kind of get an idea of comparing one to the other. Here I can see that this function is consuming more resources, widthwise than this one is. When this is your code, obviously you recognize it more. But one of the really nice benefits is I can also go to this view. And so now let's say I do the same thing where I select the, whatever it was, the south region. I select the north region. I hit execute. And so what this is going to do is now, what did I say? North region. Is so now I'm taking those two flame graphs that we were looking at side by side, overlaying them on top of each other. And similar to how you get like a git diff, it's going to tell you, okay, this is what the difference is between these two functions. And so, or between these two flame graphs. And so in this case, that flame graph on the left that was, functioning and consuming less resources was spending 160% less CPU on this specific function. And so if this were an incident, now I need to figure out exactly what I need to do to go resolve this incident. I jump in here, I see, what's shining in bright red, and I'm like, okay, clearly the check driver availability function is causing an issue that's caused by a mutex lock. And now I know exactly where to go to fix that issue. Whereas before profiling, you might just have metrics and know that something's wrong, but not exactly which lines of code are associated with that issue to then go fix it. Yeah, let me pause there. Does that make sense?
Yeah, that looks good. Can you talk a little bit more about this diff view?
Uh-huh. Yeah,
Just like trying to explain it, because flame graphs are already difficult to explain, but you have to read the flame graphs and then also learn to read the diff of a flame graph. It's a little meta.
Yeah, so the flame graph itself, like I said, so the width is representing the amount of resources that are spent on a certain function. And so what this is doing is taking those two side-by-side flame graphs and then, putting them on top of each other. And so really the way to read it is, kind of relying on the colors. Green means good in the sense that you've slimmed down the amount of resources you're using on the green areas, and red means bad in the sense that from the original query, this like baseline query here to the comparison query, you've added more, CPU time or memory or whatever it might be. And so, typically how I read this is I look for the areas that are in red, and I go in here and I say, okay, so, looking at the tooltip here, the baseline was consuming 30% of CPU on this function, and the comparison was spending 79% of CPU on this function. And so what we're calculating here is the diff between the two of those and, kind of highlighting that. I can actually also show a real world example of this that might also kind of show it. So this is an example of an actual incident that happened at Grafana. This was like a while back when we had just joined Grafana, and Grafana had just started doing whole system continuous profiling all the time. So this was an incident. We had a customer that was very unhappy. Incidents happen. But yeah, and so in this case, there was a specific, let's see, this was, this blue line here is status code 400. Obviously we're using metrics. We know that, things started going wrong. But yeah, I would just focus on this blue line here from 2120 to 2135. And then again, we tried to fix something, but then it broke again from 2140 to 2150, and then again. And so, while this is happening, again, this is just purely metrics. When you have the diff, so let me show you what this looks like with continuous profiling, is, you see these same spikes on here.
I don't
but
know
again,
if we're looking at the same thing, actually.
Oh, oops. I just realized I'm only sharing my screen and not the full screen. Let's see, stop screen. Let me present, share screen.
Live demo for you.
Yeah. That's always the way, though. It's like, I want to, is he purposely being vague because it's a real production incident?
Yeah.
That's what I was thinking.
Exactly.
So
that's what it was.
So what do you see now? Now do you see a full screen?
We do, yes.
Yeah, sorry. So that's what I was explaining. So yeah, so this was an incident that was happening. We had a bunch of errors. Like I said, I kind of just went through this. But yeah, the blue line here, bad. Blue line here, worse. And blue line here, it's getting better, but still not great. And so, this is sort of without profiling, this is kind of, where things end off. And so to answer your question about, the diff and where the diff becomes useful, is that, I kind of want to know, this is before everything was working fine. And then after everything started breaking. And so what the diff allows you to do is you can select this before period where things are working as you expect them to be. You can select this after period where, now we've selected this spike here. And now you don't just know that there was, a spike here and a spike there, but you specifically know that the difference between when things were healthy and when things started spiking is that we spent an additional, 62,000% on a specific, in this case, a async queue process loop, some loop gone wrong, doing something it shouldn't be doing. And we were able to then, go in and figure out exactly what was wrong and fix the code related to this issue. Because again, this diff is showing in red what the problem is. And so, we can go in and fix that.
Wow, that's really cool. And you're saying, I also actually didn't know this. Do we just have continuous profiling running on everything in production at all times?
Everything on, and like all apps, all services, all apps. I think we, in this drop down, there's just like, 5 or 6, because this is our, just like a demo application. But in Grafana, I think we have like 900 things in this drop down. And so every team, again, when something's going on, when they're doing a performance improvement or when they're, trying to debug an incident, they go into this drop down and just select whatever service it is. And the way we do that is we actually do 2 different types of profiling. We do whole system profiling with eBPF, which you just kind of add it and it just profiles everything automatically, adds all the, we use Kubernetes, adds all like the Kubernetes metadata to all of the profiles automatically. But we also have, we use Go for most services. And so we also have the Grafana agent, which scrapes those Go endpoints. So we kind of have two different versions of the profiling data to look at depending on the different situation.
Okay, so it's also like what you're talking about instrumentation. So you talked about how on the binary side we have Grafana agent, and then the external instrumentation we have eBPF. But there's also source instrumentation for some languages, right? There are SDKs for Pyroscope.
Yeah, let me show my screen if I can do so successfully this time. So this is kind of the two paths that you can use. So actually eBPF is done via the Grafana agent. And so we kind of describe it as either SDK implementation, which is going to be your, gem install Pyroscope, pip install Pyroscope, go get Pyroscope, npm install Pyroscope, adding a library to your actual application code. And, typically I would say developers tend to enjoy that route because they have control over the code. They can easily add that. We find that often like SREs or more like infrastructure focused engineers tend to prefer this method because it allows you to, without changing your application code, get this profiling data. And so the Grafana agent sort of goes to your application. In the case of eBPF, it like adds a eBPF program that will send that back to the Grafana agent, which then sends it back to the Pyroscope server. Or for like Go, for example, it will go look at your pprof endpoints, scrape those endpoints for the profiling data, send it to the Pyroscope server, whatever it might be, via the Grafana agent. And so it just kind of depends on which situation is more fitting for various companies' use cases. We see probably honestly equal usage of both.
How did you decide that for Grafana? Because I imagine we have both types of personas and more. So what made you decide for one or the other?
So yeah, that was one of the nice things, is that we actually built this before, so most of the SDKs existed before Grafana, or before we joined Grafana, because the Grafana agent wasn't an option at that point because we weren't part of Grafana. And so what was nice is we got a lot of users who were, like I said, more like developer focused in the open source world. We adapted the most popular open source profiling libraries from each of those different languages and made it so that they can properly send data to Pyroscope. And then once we joined Grafana, obviously there's like many Grafana users who are using the Grafana agent pretty heavily. And so we basically made it so that the Grafana agent is capable of doing things the Grafana way. And so we kind of just merged our two communities into one, and now we support both of them. And it shares, a lot is shared between them in the way that it makes it easier to maintain. But yeah, we just kind of support both.
But I guess for internal use, if there were a new team or something new that needed to be profiled, how would you go about that decision? I imagine people would be pretty open to whichever way you suggest.
Yeah, so we often, so it depends on the use case for that as well. So at Grafana, we have, like I said, we automatically profile everything that happens in Kubernetes at all. And so basically just by existing, in the Grafana infrastructure, your workloads would automatically be profiled. And we see that a lot of customers do it that way as well. And a lot of open source users just have, system-wide profiling. They profile everything. If you want more specific control, so that's going to automatically add labels, like I said, of namespace, pod, container, all the various like Kubernetes metadata. It will add those using like the Kubernetes API. But if you want to, add a specific label for endpoint or something that's more unique to your application, that's where we recommend using the SDKs, because you can, similar to like adding a trace span, you can choose what you want to say. Hey, I want to add a label to this specific code here. and sometimes people opt for that if they're really digging deeper into their applications.
Right. If they have a suspect query or something in a
Exactly.
class. Yeah. Okay.
Yeah. Yeah, I would say that's one thing. One thing that I didn't show as well as, so we've talked a lot about the the profiling in the sense of like system-wide profiling. Something that we just recently added, I think I flashed it on the screen for a second, is the ability to, let's see if I show an example here. So another thing that we have support for is basically execution scope profiling. And so this is coming out in a couple days, I think, in the next version of Grafana. Basically, if you're using traces, a different kind of profiling than just profiling all of your servers, getting a 15-second profile periodically over time. Sometimes you do want to know specifically, like you were saying, for a specific query or something along those lines. And so basically this will allow you to, if you have a 400 millisecond span in a certain trace, you can also see a 400 millisecond profile. Or if it was 5 minutes, you could see a 5-minute profile, or 10 seconds, or whatever it might be. And so this is also a new pattern that we've seen, that a lot of people are interested in getting a profile per API request or a profile per trace span. And so this is something that we've added for that use case as well. But this one, again, you would have to add the SDK version to be able to get this, because it's doing a very specific label for every single trace span. It's adding, a profile for that specific trace span. And so that's another use case where you would use the SDKs over the like eBPF approach.
Okay, and it sounds like you're advocating for a hybrid approach. It kind of sounds like you would recommend for a new company, and correct me if I'm wrong, that they consider, if it's a possibility, going the eBPF route for like a system-wide thing, so that you don't have to individually set things up as new projects come online, and then maybe add the SDK support for things where you need a little bit more information than what you already have. Is that right?
Yeah, that's perfect. I mean, yeah, we definitely recommend, and like I said, it depends on how familiar your company is with profiling. I will say for a lot of Go users, in particular, since profiling comes like native inside of the Go runtime, a lot of Go people are already familiar with profiling. And so, sometimes with that, we recommend just going with the going with the Grafana agent or the SDKs or whatever. But I would say if I had to, group, give some general advice, I often recommend going with eBPF first, just because it's really easy to get up and running and get some data. And particularly if you're using Kubernetes, it's going to add all those labels automatically, that kind of thing. And then you kind of get an idea of, okay, I think I want to dig further here. Or I want to have this extra capability or add these labels. And then you can add the SDK, and you can do both side by side.
Yeah. Yeah, that definitely makes sense. Kind of the eBPF method for the lowest barrier of entry. And then that way, then you can start seeing how you can really utilize that tooling and how it can benefit you before you start going ahead and adding everything in via the SDK.
Yep.
Yeah, that's really cool.
Yeah.
I also like that approach because it's like it follows Gall's law, which says that it's just better to start with the simplest possible system and then add on complexity if you need it. Because if you start with all of the things right away, then you would need an entirely different system to make it simpler.
Yep. Yeah, exactly. Yeah, that's the tricky part. I will say one nice thing about profiling is that it is really good at giving you that view of, in a meta way of your system, so that you can optimize your system. So like one thing that we see a lot is that we didn't expect, that we've seen over time, is people who use profiling to optimize their usage of logs, metrics, and traces. Because now they can see, a lot of people think about the overhead of profiling, but not about, there's some log line that someone added 10 years ago that is just logging mindlessly. And then it's like causing, 10% of their CPU is spent logging something they don't care about. And so it's not profiling where you start to kind of, get.
Okay, how meta do we get? I mean, do you like continuously profile continuous profiling?
Oh, absolutely. If we want to confuse everybody,
It's like turtles all the way down.
I was just gonna say that, turtles all the way down.
Yeah, like those little Russian dolls where there's like
the nesting dolls.
Yeah, babushka or matryoshka. But I wanted to ask about the sampling. You mentioned somewhere that it was by default 15 seconds. It was a 15-second interval. How does, I imagine that would affect the requirements, like in terms of storage, but also computing, if you make that shorter or if you make that longer, right? So how would you suggest people start with that? And what do we do as well? Like, is all our stuff 15-second ones?
So that was one thing that we did alter, so we initially, have everything by default 15 seconds. Like I said, we do Go profiling. So we have there's multiple different profile types for Go. You have CPU profiling, allocated space, in-use space, allocated objects, in-use objects. So there's like several different profiling types. And so what we did was, CPU we found is most frequently used by people, and some of the memory profiles were used a little bit less. And so what we did was, to decrease the amount of data that we were ingesting, we changed the interval to like every minute instead of 15 seconds for those. And then, you decrease the amount of ingested data by 4 because you go from 15 seconds to a minute. And so 15 seconds tends to be really, we find that to be the sweet spot, just in terms of, obviously, like I said, it's different depending on who you are, but we find that to be granular enough where you catch things in a very specific time frame, but wide enough where, we're not getting a profile every second, for example, or something like that. And so, that's kind of what we recommend. But there's a lot of levers that we've built in. You can change the amount, the scrape interval that you're scraping the profiling data. You can change the sampling rate that you're looking at the stack trace 100 times per second. You could change that to 50 times per second. And then now the overhead that it does cause is cut in half. And so there's a lot of levers that we have to be able to change that. But at the end of the day, I would say, most of that becomes sort of not irrelevant, but a very minor consideration, because, if you're talking, you might be decreasing the overhead from 1% to 0.5%, or from 3%.
Wow, it's that low.
0.5%. Okay. And so at that point, let's say you're operating a bunch of servers. Most of your servers are probably not operating at 99%. And so the actual impact of changing that is probably very minimal compared to, when that incident does occur, and, that, you're about to miss your SLA or SLOs or whatever. Having that information is going to be much more valuable on that side than, the 0.5% that you saved by, switching the interval or whatever. Yeah. But we still offer that just in case, like I said, we did it ourselves. So we know that those cases do occur. But for the most part, we recommend people to focus on like the benefits that they get on the opposite side versus the overhead that they incur on the front end.
Yeah, because you definitely need it when you need it.
I think Ryan just said 1 millisecond intervals for everything. That's what I heard.
Yeah.
That is not what I said. But,
that's what I heard.
One single knob that goes to 11. Right? Turn it all the way up.
Yeah, turn it all the way. I mean, we do see people. I mean, some people do really want like very, very granular profiles. And not that I don't think I've ever seen 1 millisecond, but like,
well, that's what I want, Ryan.
Like high frequency trading. Like we have some people who have used Pyroscope for that, and so it's like that's something where you do want to know this specific millisecond time range, what was going on. And so, we tried to make it as flexible as possible to support even things we don't recommend. We try to make it as flexible as possible to support those too.
So you're providing a foot gun to people, right? Where they
Exactly.
can shoot themselves in the foot. Yeah.
Yes, if they want to. We try to warn them. We have all the warnings on the foot gun, but if they want to shoot themselves in the foot, power
Okay,
to.
so a couple of questions. Okay, so Andre Ziviani said, maybe more like traces instead of metrics. And so this was when I was saying that like continuous profiles are essentially philosophically metrics. But this comparison to traces kind of makes me think of how when we had Joe Elliott from Tempo come on, and he was talking about how there is head sampling and tail sampling, where you can either decide up front what percentage you're going to trace or do it after the fact. And is there something similar for continuous profiles?
So if you're using the Grafana agent, not right now, that is on the roadmap to, via the Grafana agent, be able to control this. We're also doing a lot of work with OpenTelemetry as well, and basically trying to match the same patterns for other things. But yeah, as of right now, it doesn't exist. It's not as important for profiling. And the reason is because tracing can scale more volatilely, I don't know the word that I'm trying to say. It's more volatile for tracing, that like if you get 1 million requests, you're going to get 1 million more traces. Whereas for profiles, if you get 1 million requests, if you have a big enough server, that same server is still going to just generate, a single 15-second profile. So because of the way that it scales, it's like less important to have that ability. But again, like I said, we introduced this ability to do these traces or profiles for trace spans, and so that will actually be attached to your sampling and traces, where if you sample the trace, then you sample the profile as well, and vice versa. And so but yeah, that is a good question, or a good comment, that it is much more like, I would say profiling is almost like if you added a trace span for every single function call, that would be effectively what profiling is.
Gotcha.
And the reason you can't do that is because the overhead would be so wild. And so, profiling is kind of an extension of tracing. It just gets the profiling data through that, sampling the stack trace method, versus tracing, which when they label the spans, it is that sort of start the stopwatch, stop the stopwatch method. But at the span level and the trace level, that's much less taxing on your system than if you did that for every single, millions of functions. You're doing it for, thousands of spans instead, which is, obviously fine.
And we have another question here from Olympus Biz, who says, can you add a few example alert rules for Grafana Redis plugin? I want to display most keys hit on Redis Grafana plugin.
So that would be, I guess the answer is yes. I think that's a little bit less related to profiling in this case.
More like trace, yeah.
Yeah, it would probably be more on the tracing side. That being said, one of the things that is on our roadmap as well, though, is, and like I said, one of the reasons we joined Grafana is that now, logs, metrics, and traces exist alongside profiles. Not only that, but we can leverage some of these other signals in order to enhance profiles and have profiles enhance those signals. And so one of the things I showed some, there were some like lines there when I was showing the continuous profiling stuff, is that we can now use the like Prometheus / Mimir, kind of backend in order to set up alerts for profiles. So let's say you did have a specific function that was doing something related to Redis. In this next like couple months, you'll be able to kind of create a metric from the usage of that function that's extracted from your profile, and then be able to set some alert rules based on that. And so it's like a little bit removed, obviously, depending on, I would say the Redis case is probably better done in traces than profiling. But, I don't know. You could also be profiling the Redis like library itself and looking at things there.
Could you talk about the Pyroscope OpenTelemetry library?
Yeah, I would love to.
Because that further muddies the waters between profiling and tracing.
I think this actually does the opposite in that it
Really?
it does provide a nice delineation between profiles and traces, as tracing is obviously a signal within OpenTelemetry along with logs and metrics, and profiling is sort of the next one. And so this is a data model that we've proposed. Me and Dimitri, some of the folks from Datadog, from Elastic, from Red Hat, various other people who are doing things around profiling, and then some end users as well, have been in a SIG for the past 2 years. I think we started after the Valencia KubeCon we were talking about earlier, Nicole. But yeah, after it's been about 2 years, we've been working on building a data model for that all different profilers, whether it's Ruby, Python, Go, eBPF, .NET, etc., can all create profiles in the same format, so that again we're vendor neutral and all that kind of stuff. And so this has been proposed. You can see there's lots of comments on it. Even as recently as just 2 days ago, we are still getting a couple comments, but it's looking like we're aiming to have this data model, which is similar to pprof. It's not exactly pprof, but similar. Has some added extensions and benefits to bring pprof sort of in the OTel context. So adding things like the ability to link from a trace to a profile, adding that as like a field on the profile to make that more efficient and that kind of thing. And so we've been working towards it. We're hoping to get this merged in the next couple weeks. And then once this is merged, we'll move from the draft stage into the experimental stage, which allows for all of the language instrumentation groups within OpenTelemetry to now start exporting profiling data in this format that is proposed in this PR. And then, we start to add some of those things like this tail sampling, head sampling, all those things that exist within OpenTelemetry in the collector. We can now add those for profiling as well.
It's awesome seeing all the big names getting together with the OpenTelemetry project to add that in there, because that being able to stick with vendor neutrality and all that good stuff, that's a big deal.
Yeah. So it's been as with anything in OpenTelemetry, it's been definitely a long haul. I'll paste the link in the chat. We're definitely looking for feedback. So if people, one of the things that's most useful here is if people like the direction this is going, feel free to add some emojis to the PR. If you have questions, comments, add those. And if you support it, feel free to add a review saying, hey, I approve of this. The more reviews that it gets, the more quickly we can move and get this into the OpenTelemetry world, so that people can start getting their hands on it. So if I had one ask, I would say add some emojis, add some reviews, approvals, and if you have any questions or comments, add those too.
Yeah. And whatever you do, don't suggest that there should be an open profiling project. We don't want to do that. We don't want to split it.
No, it's not. I mean, if once you read through this, it makes sense, the format that it's in now. So we explored that, even early on, and definitely have explored all of. No stone has gone unturned, and we definitely are pretty confident that this is the best route for for the OTel community.
Agree.
We are almost out of time, but it occurs to me that we didn't actually talk about installation options. Milky asks, Ryan, can you please do some demo and show how we can make profiling? I think they mean, installation and configuration. What options do we have?
Let me show. So I would recommend, I'll send a link here. You can go to our examples folder. And this will, obviously our docs, we have, many docs that will explain this, but, whether you want to do Grafana agent, Go the push method, Go the pull method, Node, Java, etc. We have all these here. That rideshare example that I went through today, we have sort of a blog-esque, kind of walkthrough / installation instructions version here. Obviously, everybody here is using different languages, so I can't go through all of them right now. But basically, for each of these, we have an example of how you set up Pyroscope. So really, it's just this line. Let's say you're using Go. You just add this code snippet here, name your application, tell it where to send the data, add any labels if you want to add labels. And that's the bare minimum that you need if you're using Go. But yeah, we have the eBPF example, etc. So I would recommend just going here. Like I said, this is Python. It's just pip install Pyroscope, and then same thing. You add this snippet to your, actually, let me just show an example to your, let's see, like if you're using Flask, I believe it's in server.py. So yeah, so like this is all you would need to add Pyroscope to a Flask application. But yeah, we have this for all the examples. I would say I'd recommend just checking out the documentation, and we just did a giant docs rewrite, so hopefully it should be pretty easy to understand and get through. But yeah, we'll have all the information there.
All right, great. Thank you. Thank you so much for coming on the show and telling us all about continuous profiling and answering my questions.
No problem. Thanks for having me. And yeah, looking forward to seeing you all in person next time I see you, getting you some Pyroscope swag. But yeah,
I'm counting on it.
Yeah.
God, he's such a show off. Just because he has it and I don't.
Yeah.
Well, you don't have this, Paul.
Yeah. Last thing I'll say is, yeah, we're active on GitHub. We're on the Grafana public Slack. Like, feel free to in the Pyroscope channel. Feel free to reach out if you have any issues or questions, and we would love to help you get started. Or do more advanced things if you've already gotten started. So just let us know. And yeah, I think that's all I got.
Awesome. Thank you. And thank you, everyone. Paul, do you have any announcements?
Well, I think this was my last Grafana office hours. Yeah, I'm leaving. Nicole has abused me one too many times, so I am leaving Grafana.
I think it's the other way around.
Was it me? Was it something I did? I just got here.
Actually, it was. Yeah. Sorry.
Wow.
No,
Paul decided he's had enough of you.
Yeah, exactly. Now I'm going to be putting on my engineer hat again and going and actually being a heads down coder and architect and all that again. So, but yeah, I've loved my time at Grafana though. Definitely.
All right. Well,
especially this, right?
Exactly. But I still do want the updated Pyroscope t-shirt because I plan to
No. You leave the company, you leave the swag.
Yeah, I'm gonna take that shirt back right off. No, I'm kidding. No, I'll still
uninvited.
I'll still get you the updated swag.
Awesome.
All right. Well, maybe we'll still, if you're nice, maybe we'll still have you on in another capacity.
Yeah,
that's right. I want to become a Grafana champion. So
yeah, bring Pyroscope wherever you go.
Good luck with that. I wonder which team does the approvals for that. Oh, wait. All right. Well, thank you, Ryan. Thank you, Paul, for being a decent co-host sometimes.
Comic relief. That's what I'm here for.
Yeah, peanut gallery.
Yes.
Thank you, everyone, for watching, and we'll catch you next time.
Bye, all.
Bye, everyone.